Hi and welcome to the fourth SPSS tutorial for PSY 520. In this video we're going to talk about the chi-square analysis and how to conduct it using SPSS. So chi-square tests are a bit different than really everything else we've covered in both PSY 510 and PSY 520. Chi-square tests are used when you are comparing two categorical variables, so they're used when you do not have any quantitative variables. We have not been in this position before. So t-tests and ANOVAs, you had a single independent variable that was categorical, or in the case of a factorial ANOVA, you could have two categorical independent variables, but in those cases you were always testing the effect on a quantitative dependent variable. Here you have two categorical variables, and you're essentially testing to see whether or not they are independent of each other, which is another way of saying whether or not they are related to each other. So technically this test is called the chi-square test of independence. That's a test that we're going to be covering here. So let's take a look at our data. If we are on the data view here and scroll down, we can see that we have data from 60 different participants. Each row is a participant. If we click on the variable view, we can see we have a variable called party, one is called public opinion, and one is called voting age. Now, as it turns out, these are all categorical variables, so they all have values associated with them. In the case of party, we have political party, essentially Republican or Democrat in this data set. For public opinion, we have support, oppose, or undecided. So you can imagine that this is perhaps voting, the way someone voted on a proposition of some sort, their opinion on that proposition. They support it, they oppose it, they're undecided. Kind of whatever you can think of, you can imagine being used in this case. Then we have the voting age, yes or no. So this is saying basically, is the participant old enough to vote? Yes. Or are they not? No. So we actually have three different categorical variables here. The chi-square test is used really on two of them. So we're going to focus in on two of them at first, party and public opinion, when it comes to the test. So they're both categorical variables. So we cannot run a t-test, we cannot run an ANOVA because we do not have a dependent variable that is quantitative. We only have the categorical variables. But what we can do is test whether or not party and public opinion are independent of each other. In other words, is there a relationship between participants' political party and whether or not they support the proposition? So one of the first things we're going to do is go up to Analyze, and we're going to go to Descriptive Statistics, and we're going to click down here on Crosstabs. And if you go to Crosstabs, you can create a cross table using rows and columns. So we are going to put party as our row, and we're going to put public opinion as our column. So that's a pretty straightforward way to set that up. Then click on OK. And what you're going to get in the second box, the first one's just really a summary of how many participants you have. But in the second box, you are going to get what's known as this cross table or cross tabulation of your variables. So you're going to have your party variable making up your rows, a row for Republicans, a row for Democrats. And then you're going to have columns for the public opinion options, support, oppose, or undecided. And then we have our totals on the bottom, and our totals furthest over here to the right. So we can just take a look right here and get a sense for how public opinion differed by political party. We can see that for Republicans, 17 supported, 9 opposed, and 4 were undecided, whereas for Democrats, you had 10 support, 17 opposed, and 3 undecided. So clearly there's a difference. In the case of Republicans, more of them supported it than opposed, whereas in the case of Democrats, that was actually reversed. So that's suggesting that these are related, that there is a relationship between these two variables. Now, to determine that, we're going to use what's called the chi-square test. And basically what this test does, you can read about it in your textbook, but what the test does is it calculates essentially the values that you would expect if these variables were indeed independent. In other words, if there were no relationship at all between political party and public opinion, it calculates what are known as like the expected values for each of these cells. In other words, if they were totally independent, how many Republicans do we think would support it? How many Republicans would oppose? How many Republicans would be undecided? And if they're totally independent of each other, you would really have the same proportion of support, opposed, and undecided for Republicans as you would for Democrats, because after all, they're independent. There's no relationship between them. So what the chi-square test does is it basically compares what you actually have, which are known as like the observed values, to what you would expect if they were independent, which are known as the expected values. So your textbook talks a bit about comparing observed to expected, and that is how the chi-square statistic is calculated. But for now, we're going to let SPSS kind of do all the work for us. So just from looking at this cross table, we can get a pretty good sense that there probably is a relationship here between the variables. Now we just want to test to see whether or not it is significant. So we're actually going to go right back to where we were. We're going to go to Analyze, Compare Means, Descriptive Statistics, and then to Crosstabs. And it saves our last entry, so we still have Party in the row and Public Opinion as a column. We're now just going to click on Statistics. We're going to click that box for chi-square, and we're going to say to SPSS, all right, let's run the chi-square test. Click Continue, click OK, and you now get the exact same box you already saw, but now you get this chi-square test box. So the value that we really are interested in is the first row, the values in the first row. That is your chi-square test of independence for these two variables. So it is testing whether or not there is a significant relationship between the party and also public opinion. And what we can see is that we actually have a non-significant test. This p-value 0.11 is not smaller than 0.05, suggesting that it's not a significant test. Now that's fairly interesting because when we look at this, we can see that there seems to be a pretty clear relationship. But what this is telling us that it's not significant is that even though those are differences there, they are not extreme enough for them to be unlikely to be due to chance. In other words, even if these variables are totally independent of each other and there is no relationship, you may very well still get numbers like this just due to chance. So they're not extreme enough to be significant. Now part of that, if you kind of tie everything together, is that a test like this might not have all that much power because we only have 60 participants spread across these 6 different cells. If we had more participants and we had the same proportion of support, we probably would have a significant test. But for now, we do not have a significant test. So given the data we have to conclude that there is no relationship between party and public opinion. And that's a tough one because we can look at the table and it certainly seems like there is, but again, the test is telling us that even though there are differences there, they are not extreme enough to be unlikely to be due to chance. In other words, you could have gotten differences like that just due to chance. So our conclusion here is that we do not have a significant relationship between our two variables. Now, one other thing we can do with the chi-square test is we can add a layer. So we can actually say, all right, well, let's look at the chi-square test by layer, so like by another variable. So we had another variable in the data set. We had voting age. So we could look at the chi-square test just for people who are voting age and look at it just for people who are not voting age. So we basically split our chi-square test into 2 different tests or layers. To do that, because that can be useful, let's go up to Analyze, back to Descriptive Statistics, back to Crosstabs, and all we're going to do is add the voting age in as a layer. All of our previous selections are saved. We're going to click OK, and now we are going to get to this more complicated cross table. and we're also going to get to our more complicated chi-square test table. So if we break this down, if we look at the crosstab table here, we essentially have like 3 cross tables. We have one right up here, only for people who, yes, were of voting age. We have one right here, only for people who were not of voting age. And then at the bottom, we have our total cross table that we've already seen before. And there's a lot of numbers here, but if we look carefully, it is pretty interesting. We can see that for people who are of voting age, there does seem to be a pretty clear pattern where the Republicans are supporting as opposed to opposing, and the Democrats, on the other hand, are more likely to oppose. Now, if we look at the people who are not of voting age, we can see that there really isn't much difference. The Republicans are pretty split, the Democrats are pretty split. And then when we look at it in total, we see the same crosstab that we've seen before. So just visually, what this is telling us is there seems to be more of a relationship just amongst people who are of voting age than there is amongst people who are not of voting age. Now, we already know at the total level we do not have a significant test, but now we're going to kind of break it down and look at it just by people who are of voting age and then separately just by people who are not voting age. So when we do that and scroll down to our chi-square tests, we now have kind of 3 sets of tests. We have the yes for voting age test, the no, and the total. And again, the Pearson chi-square is the row that we want to look at. This is telling us right here, this 0.042, which is smaller than 0.05, that we do have a significant chi-square test for participants who are of voting age. So if we look at only the participants who are of voting age, we do indeed have a significant test. There is a relationship between political party and public opinion for participants who are of voting age. Not surprisingly, the test for people who are not of voting age is nowhere near significant. We could see from the table that there really was no difference. So in that case, we do not have a significant test. And then when we look at it in total, we have the exact same result that we've already seen before, that it is not significant at the total level. So this is fairly interesting. This is telling us that when people are of voting age, there does seem to be a relationship between political party and their support for the poll. When people are not of voting age, there's no relationship. And then when you look at all the people, you do not have a significant relationship, and it seems that that is the case because the people who are not of voting age are kind of watering it down to some extent. Like if you only look at people who are voting age, you have a significant relationship. But once you add in people who do not, are not of voting age, then you no longer have a significant test. So this is a pretty interesting example of how we can use the chi-square test to see whether or not 2 variables are independent of each other. And it's also an interesting example to point out the importance of looking at those different layers if your data set allows for it. It just gives you kind of a more nuanced look at the data. So instead of just concluding that no, there's no relationship at all, by adding the layers we can add that extra level of detail where we say yes, there is a relationship for people who are of voting age, but no, there is not for people who are not of voting age. So that is how you conduct the chi-square test in SPSS. Again, this is technically the chi-square test of independence, and it's really all based on those cross tables. So again, that's how you do it in SPSS. Take a look at your textbook for a little bit more information on kind of how SPSS is calculating it in the background, and it has to do with those observed frequencies that you've actually observed, the comparison to the expected frequencies that you would have if the 2 variables were independent of each other. But for now, that's it for the chi-square, a pretty straightforward test and pretty easy to interpret.